Alright, as promised, I'm going to work a couple problems with you. These are the most common ones people always ask. Number 4 on the assignment. We're going to solve this differential equation by separating the variables, of course. So I'm going to bring over the square root of y, and I'm going to write that as y to the 1/2 dy, and that's going to equal this 1 plus x dx. When we take the antiderivative of both sides, over here we're going to get this, what's that, x plus x squared over 2 plus our constant of integration, don't forget that. And over here we get y to the 3/2 times 2/3. Very easy to do. I think everybody can do that much right there. And what we're going to do next is I'm going to start solving for y by multiplying both sides by 3/2. So if I multiply both sides by 3/2 and distribute, I get y to the 3/2 equals, what's that, 3/2 x plus, what's that, 3/4 x squared plus c2. If I distribute that 3/2 through there. Next, I am going to solve this by taking as a power, I am going to take the 2/3 root. So if I take the 2/3 root, we get y equals all of this 3/2 x plus 3/4 x squared plus c2 to the 2/3. Now, if this was 3/2 over 2, it'd be like a square root. We'd have a plus or minus there. But we're lucky it's a cube root, so we just keep the sign the same. Our next step now is to solve for c2. So we need to find c2. And we're going to use the condition that they gave us, that initial condition right there. Plugging it in, we're going to get 9 equals 3/2 x plus 3/4 x squared plus c, plug in 2, to the 2/3. I forgot to plug in my 2, so let me go ahead and do that. We get 9 equals 3/2 times 2 plus 3/4 times the 4, because 2 squared, plus c2 to the 2/3. Simplifying this, we get 9 equals, what's that, 3 plus 3 plus c2 to the 2/3. And I'm going to solve this by taking the square root of 9 and then cubing it. And that's going to give us 27 equal to 6 plus c2. Therefore, c2 is 21. And our equation becomes y equals 3/2 x plus 3/4 x squared plus plus our 21 to the 2/3. Now on the next one, I'm going to show you kind of a quicker way we can do this. Okay, this is kind of a lengthy way. We solved first, and then we found our variable. For the next one, I'm going to show you kind of a little quicker way if you want to try it. It's a little bit easier, a little bit less time. So let's take a look at number 6 here. This is number 6. We're going to separate the variables, so I'm only going to bring the y over. This becomes 1 over y to the 1/2. Be careful, we do have to divide. dy equals, and when I bring the dx over, I get 4 natural log of x over x dx. Take the antiderivative of both sides. Now the left side is pretty easy. We get y to the, 1/2 times 2, because remember that's y to the negative 1/2. And over here we do have to use u substitution. U is the natural log of x. Du is just 1 over x dx. dx equals x du. And those x's will cancel, leaving us with 4u du. So taking the antiderivative totally now, 2y to the 1/2 equals 4u squared over 2 plus c1. And I'm going to do a couple things. One, I'm going to go ahead and divide everything by 2, and I'm going to replace my u. Y to the 1/2 equals u, which is just the natural log of x, squared plus c2. Remember, I just divided everything by 2. Okay, and I replaced my u. Now, at this point right here, I'm okay leaving this as a general solution. It's not my final answer, but I would have to square it, and then when I plug it in, I just have to take the square root again. So I'm just going to go and leave it like this to find my constant of integration. So to find C2, using the initial condition, E9, right here, there's my initial condition, I plug it in. This says 9 to the 1/2 equals the natural log of x squared, plus c2. And again, man, I keep forgetting to plug in my my x there. So just 9 to the 1/2 equals the natural log of e squared plus c2. Now the natural log of e, just 1, so I get 3 equals 1 plus c2. So c2 is just 2. Now be careful, 9 to the 1/2 is just 3, not plus or minus. We're not taking a square root. We have that. Okay? Now, had you done the whole square thing, you would have, if you would have squared this, you would have to take the square root to get plus or minus, right? But remember, my y value is positive, so I still only want the positive anyways. Don't worry about that if you didn't do that. Okay, now, plugging it back in, we now get y to the 1/2 equals the natural log of x squared plus 2, and now I solve for y. So y equals the natural log of x squared plus 2 squared. And there's our answer. Alright, so these are fun. I enjoyed it. Look at that. Less than 6 minutes for both of them. Alright, I'll see you guys later. Bye-bye.